All right, we are moving into concept 3 notes, which is about thermal energy specifically. So, a whole concept about one type of energy, so it's probably important. So, just a little refresher. Remember, thermal energy is related to heat, but we're going to give you a fancier definition now as we get into more detail. So, the fancy definition is it's actually the sum of kinetic and potential energy of the particles in an object. So when we start our chemistry units, we'll start with matter, and we'll learn about the kinetic molecular theory, which talks about how all matter is made of particles, and those particles are in constant and random motion. So they're always moving, so they've got this kinetic and potential energy that exists. Thermal energy will increase as mass increases, and it will also increase as temperature increases, because temperature is actually a measure of the average kinetic energy of particles in an object. So something with a higher temperature has more kinetic energy. And we know from concept 1 that kinetic energy is energy in motion. So that means the higher temperature objects have faster particle motion. Lower temperature objects, which we would think of to be cold, that's what would feel cold, even though cold isn't really a thing, those would have slower moving particles because they would have less kinetic energy. So, when you come into the classroom, how do you know if someone was sitting in your chair before you? Well, it feels warm. And that's because thermal energy always flows from higher temperature objects to lower temperature objects. So, if someone was sitting in your chair, they have a higher temperature in their body than the chair does. So, heat or thermal energy flowed from them into the chair, and then thus you feel it when you come into class. The actual definition of heat, because I keep saying it, and we'll use it as Q in some equations, it's a transfer of that thermal energy from one object to another. That's all. It's just a transfer of it. So when we say like that thermal energy flows, that's what we mean that heat is going from the person into the chair. Because it's a form of energy, it's measured in joules, just like all of our other forms of energy. And we will practice calculating it in a little bit. Now, I told you this earlier in the year, hopefully you remember, but there's no such thing as cold. Cold is just a feeling. When we say the word cold, what we really mean is we're feeling an absence of heat. So heat is something that actually exists and can move around. When you feel cold, it's because heat has left you. Thus, again, you feel that absence or that lack of heat. So, for example, explain what happens when you hold a cold drink and your hand starts to feel cold. So let's say you're drinking Coca-Cola and you're holding that can and your hand just starts to feel so cold. All right, this isn't because the cold on the can rubbed off on your hand, because cold isn't a thing. What happens is that heat moves, we said thermal energy, heat, it moves from higher temperature objects to lower temperature objects. Your hand is warmer than the soda can. So heat will transfer from your hand to the soda can, and you're feeling that lack or that absence of heat on your hands. And the soda can will probably start to sweat if you've ever felt it kind of sweating, and that's because you've transferred heat to it, and thus it sweats, or has that condensation, you could say. When heat flows into an object, like it would flow into the soda can, the change in heat or the change in thermal energy would be positive. When it leaves an object, like your hand, the change in thermal energy or heat would be negative. And we'll see that when we do some calculations of thermal energy in a little bit. So there's 3 main ways that thermal energy can be transferred. One is transfer by conduction. So this is transferring thermal energy through matter by direct contact of particles. So solids are the best conductors of heat because particles are really packed together in solids. We'll learn more about that in the future, but they're really close together, thus we can transfer heat between them a lot easier. So ways that you transfer heat by conduction are by wearing thick coats. The heat transfers from your body into the coat, and so then it stays all there and stays around you. When this pot or this pan are on a stovetop, the connection, the touching of the bottom of it to the stovetop is transferring heat energy by conduction. But another way we can transfer thermal energy is by convection. And this is a transfer of energy by the movement of heated particles. And this happens most often in liquids and gases. And this happens anytime there's some sort of current. So the way that you probably witnessed this in your life is anytime you've ever boiled something, like water for mac and cheese or for tea or something like that, there's this movement of heated particles. This is how a lot of air conditioning systems work too. They pull the warmer air out of the air and then the cooler air kind of circulates. So it's moving heat from warmer to cooler parts of a substance. And then last is radiation. And this is a transfer of thermal energy through the use of those electromagnetic waves. So this is happening most and fastest in gases because the particles are very spread out. So these waves aren't being obstructed by particles like they would be in a solid. Radiation can be absorbed or it can be reflected. And it can travel through space and between molecules, which is pretty cool. And we'll learn way more about this in our waves unit. Now, some materials are good at doing all these heat transfers and others are not. We would say that conductors are those materials that allow heat to flow easily. This is metals and skin. So, if you've ever cooked at all, pretty much all pots and pans are made of metal because they're good conductors of that heat. Your skin is actually a good conductor too. You've probably noticed if you ever hug someone, if your clothes are touching, you don't really feel that transfer of heat through the coals, but like where your arms touch, skin to skin, you can really feel that heat transfer well because your skin transfers heat easily. An insulator is a material that does not allow heat to flow easily. So that would be air, wood, styrofoam, plastic, fiberglass. Those are not things that hold heat well. That would be what makes up like a travel thermos, something like that. Your house hopefully has some sort of insulation that keeps the heat in. If your grandma or your dad or someone's ever yelled at you to close the door so you don't let all the AC out or all the heat out, that's because air is not a good insulator, so you want those things all closed up. Now, one more thing before we can do a little bit of math is specific heat. So this is the amount of heat needed, so that amount of thermal energy needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius or 1 degree Kelvin, depending on what unit specific heat is given to you in. So this is a specific number to different types of materials. Like cotton has a specific heat, copper has a specific heat, gold has a specific heat, tin has a specific heat. So these are like known values, not things you'd have to memorize or anything like that. You'd be able to look them up. You just need to be able to use them. We can measure specific heat by using a calorimeter. It's a tool for measuring specific heat. We're not going to probably have time to do that this year, but you'll probably do that in chemistry. Now, we want to be able to calculate heat transfer or the transfer of thermal energy, and that's my Q. And to do that, I do MC delta T. So, Q is my change in thermal energy or my heat, and that's going to be measured in joules because, again, it's an energy. M, what do you think? Stands for mass, and it has to be in kilograms. C is new. This is my specific heat, and it's measured in this funky unit, so don't worry about it because it's always going to be given to you. Delta T refers to change in T, or change in temperature. So it's your final temperature minus your initial temperature. So it'll be measured in degrees Celsius or Kelvin, kind of just depending on the situation. So let's do an example. A wooden block has a mass of 20 kilograms and a specific heat of 1,700 joules per kilogram times degrees Celsius. Find the change in thermal energy of the block as it warms from 15 degrees Celsius to 25 degrees Celsius. So, what are we looking for? We're looking for a change in thermal energy, and that is Q. We know that mass is 20 kilograms. Specific heat is my C, and then 15 degrees Celsius is my initial temperature, and 25 degrees Celsius is my final temperature. My equation is Q equals MC delta T. I'm looking for Q and it's already isolated, so I can just plug in. Now, the key is that you just do your order of operations right. So I plugged in my mass of 20, my specific heat is 1700, and then my TF of 25 minus my TI of 15. Make sure you subtract this first before doing anything else. So 25 minus 15 is 10. Now, all you have to do is multiply, and you get 340,000 joules. Now, I want you to try these two. The second one's a little bit harder because you're going to have to rearrange, but I think you can do it. So pause, and then you can press play and see the answers to see how you did.